Alright, so we're doing the squares, Sherlock and Squares problem on HackerRank. In this problem, we will be given an interval where the first value would be where our interval starts and the second value is where our interval ends. And what we want to do is we want to find the amount of square integers there are in our interval. So for this example, there are two square integers. What are square integers? Square integers are nothing but values when squared create that value. So for example, 4 would be a square integer because the square root of 4 is two whole values. So we could define any square integer as any number that when square root, it will give us a whole number. And this is a list of some square integers. Okay, so now that we know what we have to do, let's say we're given an interval of 3 and 9. So between 3 and 9, we know that there's values 3, 4, 5, 6, 7, 8, 9. Okay, so we want to find the square integers in this interval. So what we have to do is we have to determine whether these values are square integers or not. So right off the bat, we can see that 3 is not a square integer because the square root of 3 will not give us a whole number. 4 is a square integer, 5 is not, 6 is not, 7 is not, 8 is not, and 9 is. So we have 2. So what kind of algorithm can we implement to find these square integers? Well, instead of going through all of these values in the given interval, we could actually go through the square root of those values. So we know that we want to find all square integers of 3 and 9. So instead of going through the bigger versions of this, we could go through the smaller version by square rooting both numbers. So we get square root of 3 and the square root of 9. And the square root of 3 is about 1.7. And the square root of 9 is, well, 3. So we could round down 1.7 to 1 and have this new interval, 1, 2, 3. And then this would give us the two values that we found earlier, 2 and 3. Connect here. Actually, this connects here. This connects here. So notice how this value, it could still be it's still counted as a square integer because this doubled gives us 4 and this doubled gives us 9. This prevents us from going through all of these other numbers, which will make our algorithm much faster. Now, one last thing that we'd have to check is we'd have to check if the first value that we have is an integer, a square integer. Alright, so to check whether the first value will fall in our interval, we take our first value, in this case is 1, and we'll square our first value in our new interval. And the square of 1 is 1. And now we'll want to check if this 1 falls into our original interval, which was 3, 9. So 1 is obviously not in this interval, but the way we could apply this in code is to check if this 1 is bigger or equal to our start of the interval, which is 3 in this case. So now to implement this in the code, remember we want to first save the amount of square values there may be, and we will assume there are none, so we equate it to 0. And then we want to create a start, which would be the square root of our original start, because we don't want to go over the the whole interval. We want to take the square root of that and go through that small one. So we would do math dot square root a, and we want to concatenate this into an integer, because this would be a double. And we want to do that the same with the n, which is b of our interval. So we call it end. Again, concatenated math dot square root b. Okay. So now we would say our amount of square values would be equal to the end minus the start. As we said, we want to check if our initial start is in fact an integer value within that interval. So the way we do that is we get our start and we square it. So our start squared, right? And we will see, we'll say if this is bigger or equal to a, then increment amount square values. Okay. So finally, we will return amount square values, and that should be it. Okay, so it seems like we have an error. So amount square values, amount square values, square values, square values. Alright, submit. Alright,